Number 50. Unreasonable results. Letter A. What is the final velocity of a car originally traveling at 50 kilometers per hour that decelerates at a rate of 0.4 meters per second squared for 50 seconds? All right, so let's just, it says one is unreasonable, but why don't we just find some stuff? So the first thing is it tells me the initial velocity of the car is 50.0 kilometers per hour. I hate that because I got to convert, right? I mean, we're given the acceleration in meters per second squared, so let's just turn kilometers per hour into meters per second. Remember, we do this, plug kilometers on the bottom, meters on the top, figure out a relationship. There's 1,000 meters in 1 kilometer. Kilometers cancel, right? So I got meters on the top. Now I'm going to turn my attention to the denominator. I got to get rid of hours, so hours will go in the numerator, all right? And I know the relationship between hours and minutes. I'm trying to get smaller in the denominator. Therefore, I know 60 minutes in an hour, so the hours cancel, right? Now I got minutes, but I don't want to know meters per minute. I want to know meters per second, so I got to get rid of the minutes. So the minutes go on the top, seconds on the bottom. I do know the relationship, 60 seconds for every 1 minute, so I can cancel the minutes. And lo and behold, 50 times 1,000 divided by 3,600. So we get 13.9. All right, 13.9 meters per second. Okay, that's the initial velocity. Now it says it decelerates at a rate of 0.4. What does deceleration mean? It means, it doesn't necessarily mean negative acceleration, but it'll mean the opposite sign to the direction of travel. So I'm just going to assume, right, that this car is going, looks like a wheelbarrow, but I'm going to assume that this car / wheelbarrow is moving to the right. Therefore, the deceleration would be opposing that or going to the left, and I would have to show that by giving a negative sign to it, okay? So the acceleration here would be negative 0.400 meters per second squared. And it says that the time that this acceleration is occurring over is 50.0 seconds, all right? And it says, what is the final velocity? So I want to try to find the final velocity here. So that's a question mark, right? So all we have to do, this is purely kinematics. I mean, just think back to, kinematics. How do I need a formula that relates for these variables and allows me to solve for the VF. Which one might it be? It's the easy one, right? The one we all like to work with. Final velocity is equal to the initial velocity plus the acceleration times time. Final velocity is the unknown. The initial velocity we found to be 13.9. The acceleration here was negative 0.400 multiplied by, but the time value of 50 seconds. So all we got to do is plug it into the calculator. So what do we get here? So 13.9 times negative 0.4 times 50. Whoa. Is that even right? No. I got negative 278. It's a little off. The plus sign turned into a multiplication sign somehow. But again, I'm always checking to make sure the answers are reasonable because I realize when I get a value like that, something went wrong somewhere. So it's 13.9 minus 0.4 times 50. Good value. That sounds a lot better. Negative 6.10 meters per second. So why is that value unreasonable? Well, what does the negative sign tell you? Negative sign in terms of velocity tells you direction, correct? So what that means is that according to my car wheelbarrow here, it was traveling to the right. It had a positive initial velocity, right? Notice that this value here is positive, okay? And it kept traveling, and then it stopped, and then somehow it started to go back, right? Because my final velocity is now negative. I mean, I don't know about you, but when I decelerate my car, I generally come to a stop. I don't know how to go from, drive to reverse without, continuously, let's say. All right. So I think it's a little unreasonable that the final velocity here would be negative 6.10. Unless the car maybe was going up a hill, right? I mean, that's possible, right? We have a hill here. Here's my Tesla. Okay. I don't have a Tesla. I'm just saying that this looks like, well, it doesn't at all. Anyway, it's something, some vehicle with two wheels, a bicycle that's square. So it's traveling up the hill, and let's just pretend that I throw it in neutral, all right? And its initial velocity were to be 13.9. Then what would happen is, it would travel up. It would come to a high point and then travel back down because it's in neutral, All right, but I don't know. Maybe that's how the problem is created. I don't know. It doesn't give me enough information, but that would be what's unreasonable about it. What premise is unreasonable? I don't know. Maybe the initial velocity wasn't measured right, or maybe the time is too long. Could be a whole bunch of things. Anyway, guys, thanks for tuning in. I hope this helped. Please do remember to subscribe. That would be awesome, and I'll see you in the next video.